All right, what we're going to look at today is multiplying rational numbers. So rational means we can have positives or negatives. So we're going to start off kind of learning about that, but also means we can have fractions and decimals. So just a reminder of what multiplication is. It is repeated addition, and we are going to use that definition quite a bit today. Repeated addition. So 3 times 5 is simply that we have 3 5s. We have 5 added together 3 times. If you ever see a number next to a variable, it just means multiplication. So also if you see a number next to parentheses, it means multiplication. So we don't write the multiplication sign, just understood that 3x means 3 times x, and 3 parentheses 2 plus 5 means 3 times 2 plus 5. A couple other things, a product, that's the answer to a multiplication problem. So if you hear the word product, you need to know you're multiplying. And a factor is any number that is being multiplied in the problem. So factors are multiplied together to give you a product. So we have factor, and it doesn't have to just be 2 of them, but I'm just going to write 2. Factor times factor equals a product. And we can have as many numbers as we want for factors. We could have factor times factor times factor times factor times factor equals product. Here's some key things that you've learned in the past about multiplication. It has the commutative property, which really just means you can switch the order. So commutative property has to do with order. Associative property means you can regroup. Identity, when we talk about identity, we talk about what can you multiply something to still get that number. So a times what still equals a? Well, a times 1. So 1 is the identity for multiplication. Distributive property, and we talked about how this means multiplication here. A times b plus c. That just means a gets multiplied times b, and a gets multiplied times c, and you use that sign there. And the zero property of multiplication basically says anything times 0 is 0. So those are our properties, and now we're going to get into a little bit of investigations. And so to start this, it says rewrite the multiplication problems as repeated addition. The first one's going to be nice and simple. This first part 1. So what we know here is, and we actually did this one already, this is 3 times 5. So this means we have 5 plus 5 plus 5. 4 times 7, well actually, so this is 15. 4 times 7 is simply 4 7. So 7 plus 7 plus 7 plus 7. And that is 28. 3 times negative 4, that means we have negative 4 plus negative 4 plus negative 4. So we have 3 negative 4s. Well, what is negative 4 plus negative 4 plus negative 4? That's negative 12. So and then we'll do this last one. We have 4 times negative 12 plus negative 12 plus negative 12 plus negative 12. So we have 4 negatives added together, which gives us negative 48. So here we see, hopefully, that you have a positive times a positive gives you a positive number. So looking at these first two, a positive times a positive, I'm just going to write in symbols, positive times positive equals a positive. And that's how we're going to look at these things. If we have a positive, so C and D, we have a positive times a negative. And that gave us a negative. And the reason that gave us a negative is we're just adding together several negatives, which is going to be a larger negative number. So those are two rules we see there. We can write them out in words too. Positive times positive equals positive. Positive times negative equals negative. Well, in this one, I'm going to start the rule, and we see that we have a negative times a positive. Well, what we're going to do, it says use the commutative property to rewrite the multiplication problem with positive first, then evaluate. So by commutative property, and the reason I'm going through this, I want you to see why these rules work. This is the same as 4 times negative 5. Well, this fits this form, a positive times a negative, so we know it will be a negative answer. We also could have gone back and done negative 5 plus negative 5 plus negative 5 plus negative 5 and realized it's negative 20. But since we just learned this rule, we know that a positive times a negative is negative. So this is negative 20. This one, using commutative, switch the order, we have 5 times negative 11. Really is negative 11 plus negative 11 plus negative 11 plus negative 11 plus negative 11. Well, we don't need to do that. Same idea. We know a positive times a negative is equal to a negative, so negative 55. So we use commutative property and this rule up here. Well, which brings us to a new rule. A negative times a positive, negative times a positive is negative. So that's what we have for those. We actually have one more thing we need to look at. So we have a positive times a positive times a negative, and a negative times a positive. The last situation is a negative times a negative. And to do this, we are going to look for a pattern. There's a couple different ways to discover this, but we'll look at a pattern. So part 3, by the rules we just learned, a positive times a negative is negative, so 3 times negative 5 is negative 15. 2 times negative 5 is negative 10. 1 times negative 5 is negative 5. And 0 times negative 5, we read in our rules earlier, 0 times anything is 0. So as we work down 3, 2, 1, 0, we're counting up by 5s. Negative 15, negative 10, negative 5, 0. So what's going to happen as we keep moving down? 3, 2, 1, 0, negative 1, negative 2, negative 3. Well, the pattern continues. We'll keep going up by 5s. Negative 15, negative 10, negative 5, 0, 5, 10, 15. So we looked at a pattern. The pattern is true. We can't do everything like that. And we could talk through this a little more to show why it works, but we'll leave it at this for now. But we see here by these 3 that a negative times a negative is a positive. And that's kind of the odd one. But if we think through it a little bit, it makes sense. It's kind of like English. If you have 2 negatives, then you have a positive. A double negative is a positive. Same thing here with multiplication. But please don't try to start applying these rules to adding positives and negatives. We're going to figure out one more rule here. And I don't know if this one's as obvious for you to figure out on your own, so I'm going to help you out here. We're going to multiply these. So let's multiply across. We have a negative 2 times a negative 5. A negative times a negative is positive. And then we have 2 times negative 3. And so we're going to keep going. 10 times 2 is 20. So we have 20 times negative 3. And that's negative 60. So we had 4 numbers multiplied together. 3 of them were negative. And so we got a negative answer. Here we have 4 numbers multiplied together. And I'm going to kind of change the order a little bit how I do this. Let's look at this. What's negative 2 times negative 2, or negative 1 times negative 2? Well, that's a negative times a negative, so it's positive. And then negative 3 times negative 4, well, that's a negative times a negative, so it's positive. And so now you have a positive times a positive, and you get positive 24. So the nice thing about this is when you are multiplying and you have pairs of negatives, pairs as in 2 negatives multiplied together, that will always be a positive. So pairs is 2, which really means if you have an even number or an even amount of negatives, then your answer will actually be positive. If you have an odd amount of negatives, like we did in example N, we will have a negative answer. And so that's a nice, helpful rule to use. So let's just Look up here, positive times a positive is positive, positive times negative is negative, negative times positive is negative, negative times negative is positive. So a nice rule to remember if you think through all those, I'll write this one on the other slide. We showed that a negative times a negative is positive. So looking at these two, these gives us positives. Well, notice the signs are the same. So we could say if the signs are the same, we get a positive. If the signs are different, we get a negative. And that's when we multiply groups of like two things together. If we multiply more than two, we can think an even amount of number of negatives is positive and an odd amount is negative. So we should be able to speedily go through these and figure those out. So I'm going to leave those last ones for you to work through using those things we just talked about. Here's a reminder on multiplying with fractions. It's not necessary to have a common denominator. In fact, it usually makes it harder because you're working with bigger numbers. Canceling or simplifying or reducing usually makes it easier. And when we reduce, we can reduce something from a numerator with something in the denominator, or vice versa, denominator with numerator. And another key thing, mixed numbers must be converted before you multiply. And when I say must, that's really the easiest way to do it. You can multiply mixed numbers, but it's kind of a pain. So we're going to multiply straight across, but before we do, we're going to remember that we can simplify or cancel first. So notice 2 goes into 2 once, and 2 goes into 8 4 times. We look at anything else, a 5 and a 4, a 5 and a 7, nothing else reduces or simplifies or cancels, so we can multiply straight across. 5 times 1 is 5. 4 times 7 is 28. And we had a positive times a positive, so our answer is positive. The next one, same idea. We can try to simplify first. 3 goes into 3 once, and 3 goes into 6 2 times. We can multiply across. 1 times 1 is 1. 2 times 4 is 8, but realize we have a negative times a positive, and we know if a negative is multiplied times a positive, we get a negative. So our answer is negative 1/8. So don't forget about the signs. The last one, there's a couple things we'll think about, but to start off with, we know our answer is going to be positive. Even if we don't figure it out yet, we know it's positive because we have a negative times a negative. Remember, if we're multiplying with mixed numbers, it is helpful to write them as improper fractions. So we're going to change this to negative. Some folks get confused with this. You keep the negative here, and then you still do your normal thing. 3 times 2 is 6 plus 1 is 7. Don't do any subtracting in there. So 7/3 times negative 2/7. Well, 7 goes into 7 once. 7 goes into 7 once. 1 times 2 is 2. 3 times 1 is 3. And we had a negative times a negative, so it is a positive. I'm not going to do this one. We've done these before. Multiply with decimals. We know we're going to get a negative because we have a negative times a positive. And when you multiply that, 531 and 428, you'll get different things here. You'll actually have 3 lines. You'll line up and add them, and just remember at the end, start over here with your decimal, but move it 1, 2, 3, 4 places to the left because you have 4 decimal places in here. The last thing is just a reminder about converting and how we can use unit multipliers. A unit multiplier is really a fraction that is equal to 1 because the same thing's in the numerator and denominator. So it's whenever you have something divided by itself, it's equal to 1. Here's a few of them. What you want to do whenever you're converting, you want what you're getting rid of. So here we're getting rid of inches. You would want that to be in the denominator. We don't have inches to centimeters here, so I will tell you that there is 1 inch, or 1 inch is equal to 2.54 centimeters. And so you can use a fraction of either 1 inch over 2.54, or you can use 2.54 over 1 inch. So that's what you can use for example A, one of those, and what we do is we want to cancel inches, so we want inches in the denominator, so we would use this one here. Inches to feet, well that's using one of these two. We're canceling inches, so we want inches in the bottom. And miles to inches, well I don't have a miles to inches thing here, but we would have to do this in 2 parts. So we have 2 miles, and I'll show you how to do this. We want to cancel miles. Well, we don't have miles compared to feet anywhere here, but we do have this one. So we can multiply by 5,280 feet over 1 mile. The miles will cancel, but now we have feet. Well, I still don't want feet, so I want to cancel the feet, and I want to get to inches. So I'm going to come over here and realize, well, I'll use 12 inches, because that will give me the inches that I want over 1 foot. The feet will reduce or simplify or cancel, and you'll multiply across and you'll get your answer in inches, because the only thing that's left here is inches. So it's going to be 2 times 5,280 times 12 inches.